So in order to understand what exactly is happening in the physical world, hence physical science, we need to understand motion. And so the best way to understand motion is by looking at Newton's laws. Newton, the famous mathematician from 1500s, 1600s, I don't even know, somewhere in England. He came up with 3 laws that help govern all of motion. So the first one is the law of inertia. Inertia just means that things are inherently lazy. Things want to do what they're doing forever. So right now, this piece of chalk wants to hang out right here forever. It is not going to move until another force acts on it. The other laws help describe what those forces are, but I want to dive in depth to inertia for just a minute. Inertia comes from a quantity called mass. Mass is the ability of an object to resist movement, to resist change in whatever it is doing. Now this goes against the grain for a lot of you. You think that if something is moving, you must continue exerting a force on it, pushing on it, in order to keep it in movement. But you'll find that when you go out into space or in frictionless areas, that things will keep moving forever, whether they're worked on or not by something. So this inertia concept comes from mass. His second law can be summed up in this equation. Force equals mass times acceleration. A force is something that causes an acceleration of mass. This equation works whichever way you want to work at it. Acceleration is caused by forces and is influenced by mass. This is force, this is mass, this is acceleration. From here we need to quantify and kind of define some vocab terms. Velocity. Velocity is speed plus a direction. If it's just a rate, like miles per hour or kilometers per hour, it's just a speed. But as soon as you add a direction, up, down, west, east, south, north, whatever it is, as soon as you add a direction, it becomes velocity. Velocity is speed plus direction. So now our second term is going to be acceleration. Acceleration, very simply defined, is a change, delta triangle means change, in either speed or direction for an object. And these are caused by unbalanced forces. These forces are governed by Newton's laws. An object that has mass, has inertia, is going to act in such a way that it accelerates by a force on another object. These unbalanced forces can come in a variety of ways. They can come from all of those interactions we talked about in the first video. Things like gravity, the electromagnetic force, the nuclear strong force. All of those forces can cause things to accelerate. So I want you to write this in your notes and pound it into your head. An acceleration is caused by an unbalanced force. So if there are no unbalanced forces, then it is not accelerating. It is proceeding in a constant speed and constant motion. So let's define up here constant motion. Like I said before, things want to be lazy. Things want to keep going wherever they're going forever in that direction. And so things do not want to be accelerated. They want to keep moving in constant motion at a constant speed forever. And then you act on it with an unbalanced force. That's what causes an acceleration. Newton's third law is the one that students struggle with the most. So we'll spend special detail here. His third law has a variety of names. I'm going to call it force pairs. What this is describing is that if you take an object and bring it close to another object and they interact in some way, they exert an acceleration on each other. Both objects are going to feel the exact same force coming from each other. The easiest way to explain this is to do it in the context of gravity. Right now, or you sitting in your chair watching this video, you are sitting down and gravity is holding you to the earth. You also are pulling the earth toward you. It's kind of a mental workout to try to figure that out. But if you are right here on the earth, you have mass, the earth has mass, you have gravity, the earth has gravity. And so you are exerting the exact same force on each other. The force is the same, but your masses are different. And so thus you accelerate differently. We are so small compared to the earth that we don't even notice the effect of our mass on the earth. the Earth pulls on us a whole lot more than we pull on the Earth, because the Earth is absolutely enormous. So to sum up, Newton's 3 laws: inertia, force is equal to mass times acceleration, and force pairs, also known as action-reaction pairs. We'll see you in the next video.